Okay, I'm back. I'm sorry. I suddenly pressed a stop button. Okay, so let's continue. Okay, this is electric force. So what is the difference between electric force and electric field? So by the name itself, force is F, and then electric field should be symbolized as E. Okay, so E has two equations actually. Okay, you can have another equation you find as E equals to F per Q. Okay, but this one, okay, I'm going to explain to you on this equation. Okay, so for electric field also it's a vector. Okay, so when it is a vector, it comes with magnitude and direction as well. So the equation to find the magnitude is given by kq over r square, so don't forget the square here, and then it is for every charge you have. So it means if you have one charge, you have one electric field. If you have two charges, you have two electric field, and then so on. Okay, so the direction is different than force. Okay, the direction is given by the type of the charge itself. So if it is negative charge, then all the electric field will go towards the charge, and if it is positive charge, all the electric field will go outward. Okay, out from the charge. So I give you two examples here as well. Okay, so let's see the first one. Let's say you have Q1 and Q2 given like this, and normally for electric field, normally they will ask you to find the electric field at certain point. So let's say you have point P here. Okay, this is the point P. So how do you define what is your net electric field at that point P? So again, it depends on the nature of the charge. So since you have two charges, means you will have two electric field. So starting from that point P, okay, it cannot go to charge, positive charge. It's because for positive charge, the nature is outward. So that means electric field will start from the charge, but at point P, it will go towards the right. So your E1 is to the right. Whereas for charge Q2, okay, you will see that E2 towards the right as well, because the nature of negative charge will have electric field go towards the charge. So in this case, you will have E net equals to E1 plus E2. Okay, referring to another point. Okay, I give you another two point here, but P is somewhere around here. Okay, so you have one charge positive, one charge negative. So supposedly this is charge 1 and this is charge 2. So how do you define electric field at point P? So this is point P. So since you have two charges, means you will have E1 and E2. So E1 will refer to charge 1, and charge 1 is negative. So that means from point P, you must have the arrow towards the charge. So it goes downward. And then from charge 2, since charge 2 is positive, okay, it cannot go to the charge because it should be outward. Then from point P, it will go to the opposite direction. So you will see here E2 is not perfectly horizontal, not perfectly vertical, so you need to have E2y and E2x that in the different direction like that. So how to find your E net at P? Okay, you need to calculate one by one, horizontally and vertically. Summation along horizontal gives you negative E2x. Why? Because this one is going to the left direction, and then vertically you will have two vectors. E1 is already perfect downward, E2y is supposedly upward, so you will have E2y minus E1y equals to summation of EY. So this will follow the calculation for direction of electric field. For angle, a direction is given by angle, magnitude is given by this calculation. So I think you are familiar with this form of formula. So yeah, that's it for electric field and electric force. So please do a lot of exercises, then you will see the differences and the trick. So they are actually interesting, so try as much as you can. See you again. Bye bye.